Hello, my darling. Hello, my baby. Hello, my ragtime gal. I thought I'd be silly here. Let's finish up this video. We got one. Ooh, we're doing integrating even and odd functions. So, recall even functions. Y is like c, x squared. C is a constant here. X squared, x to the fourth. Cosine's an even function. When we stick in negative x, we get the original function. So I show an example with f of x. We stick in negative x, we get negative x squared. Negative x times negative x is positive x squared, and that's just the original function. Odd functions have an odd exponent, and sine and tangent are also odd functions. I didn't do cosine up here with an even function, but I did do sine, so you can see how it works out. Cosine is done similarly. Odd functions, when we stick in a negative x, we get a negative out front. Okay? So if I stick in negative x into x cubed, negative x times negative x times negative x, there's three negatives, so that's an overall negative. And then the x cubed is negative, and that's just negative what we started with. How do we get sine x sticking in negative x that we get negative sine x? So if I stick in negative x, I have sine of negative x, and I can write that as sine of 0 minus x. And what we're going to do there is we're going to do sine of a minus b. Oh, yeah. Pull out that trig knowledge, that stuff we did. We did worksheets on this. You've done this. Sine of A, cosine of B, minus cosine of A, sine of B. Sine of 0 is 0. Cosine of 0 is 1. And we just end up with negative sine. Ooh, I don't want to do that. We just end up with negative sine x. And negative sine x is negative of the g of x. So those are even and odd functions. That's just a reminder. These are the rules when we integrate. And it has to be the same for both. We have to have, notice I have negative a here and positive a here. It's the same on both. So I could be doing, I'll leave that there. I could be doing like negative 1 to 1. I could be doing negative pi squared to pi squared. It just has to be the same on top and bottom other than the sign. Okay. When we do the even function, instead of doing this, we can do double 0 to a. And on odd functions, if you have negative a to a, it just always equals 0. Now, you never need to take advantage of this property, but, well, sometimes the work, not necessarily in Calc 1, but Calc 2 or Calc 3, the work can get really tedious if you don't take advantage of these properties. But you don't have to use them. You can always calculate it and see that you get it. We're going to do x squared both ways. So we're going to do x squared from negative 3 to 3. I start off doing this version. So I did double 0 to 3. When I integrate x squared, I get 1/3 x cubed. So I got 2 times 1/3 times 3 cubed minus 0 cubed. This ends up being 1/3 times 27 is 9. 9 times 2 is 18. We get 18. What if we would have done it the other way? Just start with the original when we integrate, still 1/3 x cubed, but now we're doing 3 to negative 3. We have 1/3 times 3 cubed minus negative 3 cubed, which is 1/3 27 minus negative 27. And I just distributed because it's easier to see what it looks like, how it gets to 18 there. And I printed out, I loaded up a picture from Desmos to like show you why. Look at this, like this side here, that area there looks like identical to the area over here. It just looks like a mirror. So they're the same one. So rather than doing it twice, we just put a line down the middle and do it once. And double it. Okay? Why don't you guys give this one a try? Negative pi over, oh shit, I already got half of it written over there. Negative pi over 2 to pi over 2 is 4 plus. We're going to do 4 plus cosine x here. We can treat that as 2 to 0. 2 times 0 to pi over 2, 4 plus cosine x dx. Integrating 4, we get 4x. Integrating cosine, we get sine. And I've got 2 times 4 times pi over 2 plus sine of pi over 2. And then minus 4 times 0 minus sine of 0. That just ends up being 2 times 2 pi plus 1, which is 4 pi plus 2. This was my integral, or what I get when I integrated, and I can just do that rather than doubling it. I can do it with the original boundaries. So that's what I did here. Negative pi over 2 to that. I've got 4 pi over 2 plus sine of pi over 2 minus 4 times negative pi over 2 minus sine of negative pi over 2. That is 2 pi. Sine of pi over 2 is 1. Sine of negative pi over 2 is negative 1. The negatives cancel out in both spots, turning into pluses. And you see we end up having 2 of these and 2 of those. And that's like seeing the double action going on. We still end up with 4 pi plus 2. Okay? Let's take a look at x cubed. We're going to go from negative 2 to 2. If we integrate that, we get 1/4 x to the 4th from negative 2 to 2. I just did the work here. We got 1/4 2 to the 4th power minus negative 2 to the 4th power. 16 minus 16 equals 0. And we can see, if we just like zoom in on that, like this area here is the opposite of that area there, but they look like the same shape. Like if I flip this up and I made it like upwards, like if it went upwards, it would look like that. But it's the same thing. So it looks like the same thing, like a reflection, but it's negative. So that's why it ends up being 0. Okay. Oh, there we go. Let's go full size. So where do we want to take advantage of this without having to integrate everything? What if we had like x to the 7th minus x to the 5th plus x cubed minus x plus sine x minus tangent of x, and we're going from negative 4 to 4. Every single one of these is an odd function. And since they're all odd, each one has an integral of 0 when we go from negative a to a. So I didn't do the math here. That would have taken a while. We're going to be smart, take advantage of it. I did throw it in Desmos. The way you can get some shading here. Oh, I showed it up here too. The way you get shading is you do like less than or greater than. And just this one is kind of like wild card. You got to kind of see what it looks like when you set it up. But then like put in the regions that you're looking at. So for y, where it was x cubed, I did 0 to 2, and that was different. And then and that's different from what it looks like from negative 2 to 0. And then I picked, after I saw what was happening with the shading, I added in these and picked these so that it looked right. Pick the inequality signs. It's kind of neat the way you can do it. Have a similar thing set up here. These actually look like triangles, but they're not. Like it's got a slight like bend to it. But A1 equals A2 here, so but A2 is negative, so when we add them, they go away. All right, let's up the game. Let's up it. Let's try something difficult. I want you to do this one. Pause the video and figure this one out. Be smart. Take advantage of odd and even. What's odd, what's even? Separate them into what's odd and what's even. All right, I'll assume you did. All the even ones are the ones with an even exponent and the constant. All the odd ones have an odd exponent. These go to 0. So I only have to integrate some of them. And I can change that to be 2 times 0 to 1 of the same integral, which saves a little bit of work and makes the next step less painful. I've got 2 times 1/7 x to the 7th, and we integrate x to the 6th, we get x to the 7th, 1/7 x to the 7th, integrate x to the 4th, we get 1/5 x to the 5th, integrate x squared, we get 1/3 x cubed, and we integrate 1, we get x. Plugging in the 1 just gives me all of that, all the original decimals. I guess I could add in, if I wanted to, minus 2 times 0, because 0 and everything is canceling everything out. I went through and got a common denominator. I got 352 over 105 as an exact answer. I hate using my calculator. I like practicing using my brain. It's good for you. It helps build your math skills in the long run. If you don't be lazy and grab the calculator every time, math gets a lot easier. And that ends up being about 3.35. Or we could have integrated each of those individually, stuck in 1 and -1. And 1 and -1 aren't too bad, but if it would have been -2 and 2, oh God, you would have hated life. It would have been ugly AF. Okay. That's all we got here. Peace.